In 1955, the world lost one of its greatest minds, Albert Einstein, to abdominal aortic aneurysm, or AAA, a condition in which the wall of the aorta, the largest artery in the body, weakens and begins to balloon outwards. If it bursts, death soon follows. AAA is very common, with 200,000 people diagnosed in the United States each year. It's been almost 70 years since Einstein's passing, and yet the cause of AAA remains a mystery. Today, surgery is the only treatment, and no medical therapy exists, putting patients who are unable to access timely surgical care in a precarious position. Our lab believes that rogue platelets are a key culprit in this mystery. We tend to think of platelets as just cell fragments that help make the scabs on our cuts, but it's been shown that they play an important role in telling our immune system what to do and in driving inflammation. To study the role of platelets in AAA, we expose mice to high blood pressure and high cholesterol, the same risk factors as in humans, and we try to cause an abdominal aortic aneurysm. When we try this in mice that have no platelets, we find that they're completely protected against aneurysm. In other words, getting rid of all of the platelets actually prevents AAA. But are all platelets to blame? It was long believed that the bone marrow is the only site of platelet production in the body. But it turns out that the lungs are also an important producer of platelets, accounting for nearly half of all the platelets in circulation. What's more, the platelets made in the lungs are known to have a more rogue and pro-inflammatory character than those made in the bone marrow. To study this, we made platelet tracking mice that have red platelets in the lungs and green platelets in the bone marrow. And when we looked at the aortas of mice that had developed a AAA, we found many more red lung platelets than green bone marrow platelets. What we did next was really interesting. We exposed mice to radiation and lead shielding and created mice that only produced platelets in the lungs. And these mice formed huge aneurysms. When we did the opposite and made mice that only make platelets in their bone marrow, they were completely protected. To show this another way, we infected the lungs of mice with a gene-editing virus that instructs cells to stop making platelets. And these mice were also protected against AAA. What all of this tells us is that the platelets made in the lungs are a clear culprit in AAA. This presents an exciting opportunity to finally create a medical therapy that can save the next Einstein and cure AAA once and for all. Thank you.